наши спикеры. И прямо сейчас мы напрямую подключаемся к нашему спикеру из Финляндии. К нам присоединяется Feruzjon Muyassarov, софтвер-инженер, специализирующийся на оптимизации Kubernetes и управлению ресурсами. Прямо сейчас Feruzjon, мы подключаемся к нему. Feruzjon, надеюсь, вы нас слышите. Алло. О, вот,
Здравствуйте.
появился.
Да,
Здравствуйте, Feruzjon. Просим, сцена ваша, floor is yours. Прошу.
Окей. Ассаламу алейкум, всем привет. Я буду на английском, надеюсь, никто не возражает. So, hi everyone, my name is Feruz, like I was introduced. I work for the Ericsson Software Technology. And today I wanted to share a little bit about dynamic resource allocation, or DRA, but of course with our national cuisine OSH, which would be impossible without. So let's get started. So dynamic resource allocation. If you're in the area of Kubernetes, I assume most of you are. You probably have heard at least what the array is, but if not, that's still okay, because I'm going to give you a little bit of introduction what it is, and then we'll talk about some technicalities. So the array, in short, basically introduced a new way for let's say cluster admins to request and allocate and share some resources which are not only the native resources. By that I mean you could basically, with the DRA nowadays, share or allocate the GPUs, FPGAs, network interface cards, RDMA, and so on. So normally you could allocate some resources like the memory, huge pages, and then the CPU, but with the help of the DRA, people started also allocating the network interface cards and GPUs and so on. So if you are familiar with how the GPUs were allocated prior to the array, then you probably know what the device plugin is. So the device plugin model was kind of the other way of allocating non-native resources, or extended devices, so-called in that context. But the array is much richer. It's kind of, let's say, the improved version of the device plugins, because with the D array, you don't only ask how much resources you need for your for your workloads, let's say for your pods, but you could also say what you exactly need and on top of how much you need. So just some basic stuff about the D array. It was originally introduced in Kubernetes version 1.26. That was the alpha state that it started developing. I think it's been like 4 years now. 1.31, it was like huge major redesign. The APIs were rewritten and so on. And then eventually, basically, in 1.34, it entered into GA, so the people started using it in production. So it's safe to use in production nowadays. And then in the latest Kubernetes release, which is 1.36, there were some new features that were introduced, and it's still being developed. But before we talk more about the array, let's order some OSH, because most of you are a fan of OSH, I guess, as I am. So the reason I'm talking about OSH today is that it's basically, think about it as an analogy to the D array. So for a moment, you could just totally forget about the D array and then concentrate on the OSH. Usually when you go to a restaurant, let's say you order OSH, right? Well, nowadays it's much improved, but previously, a few years back, when you go to a restaurant, you could just order the OSH and then you get whatever is available on that day. So whatever the cook has prepared, you just get that OSH itself, which was the fixed combination. So it would normally include like a rice, meat, carrots, oil, blah, blah, blah. The only thing you could say when you're ordering the OSH is that either give me this much portion or this much portion. So you could say, give me 0.7 or 1 portion, or just whole kazan and everything. But you couldn't say more than that, right? So the question is, can we improvise? We did. I think nowadays there are so many restaurants that are offering wide variety of the OSH. For example, nowadays, apart from just ordering the OSH, you could actually add some extras. Like you can now say, hey, give me 1 portion of the OSH, but please add extra eggs. Please add extra kaze, more meat, less oil, this and that, and so on, right? So basically what you're doing is that you're not just ordering the osh, you are also specifying the preferences that you have. Maybe you have some special diet, so you could just also mention that whenever you're ordering the osh. So now if we try to order accelerators instead of the osh, so before the D array, like I said earlier, we had the device plugin model. So you could order some GPUs for your workload. The way that you order is very simple, right? So in the pod spec under the resources, you have the limits and then the request, and then you say, for example, hey, for my pod, I need 1 GPU, and then that's the request, and that's it. You couldn't say, give me GPU with these capabilities configured in this way. There was no way to do that even with the device plugin, and that was just the integer number. So you just say the number of the resource that you need, and that's it. That's the end of the story. But nowadays, what we want is that with the D array, apart from saying just give me 1 GPU, you're also saying, actually, I want the GPU which has this product ID. For example, in our example is the A100 SX blah, 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 and then 40 gigabytes of the memory, this much of course, and so on, right? So you're now requesting a bit more, or like you have preferences on top of what how much you need. So that's what the array basically, in a very short, what it helped us in terms of the resource allocation. So when we're talking about the D array, there are usually 3 types of the roles or the players. It's not like official, but it happens when you're using the D array. So it's basically the driver developer, the cluster admin, the application developer, or the DevOps people. So the driver developer is basically someone who is actually writing the DRA driver. So the question is what the DRA driver is. So the way that DRA works is that it's part of the core Kubernetes. So if you're using the Kubernetes 1.34, it's by default on, so you get all the APIs, all the CRDs. But the API itself doesn't do anything, right? So it's the API for you to consume and allocate some custom resources, or let's say some accelerators. But you need something that actually understands how the hardware works under the hood, how to allocate the resources, how to count the resources, how to tune the resources. So you need some piece of the software that can do that. And that piece of the software is called basically the driver. So, and there are people or the companies or like the vendors who are writing the drivers. So the driver developers basically know how to interact with the hardware. They know how to allocate the resources, and then they basically introduce the APIs so that the consumers of those APIs could allocate the resources. And then when those driver developers are writing the drivers, they basically can decide what are the attributes of the hardware that they want to expose to the Kubernetes level, or what kind of interfaces to build basically so that people could consume during the consumption and try to configure or tune the hardware. So the next role is the cluster admin. So the cluster admin is someone who will consume the driver. So the vendor has developed and published the driver. Now there's a Kubernetes cluster running the production application, and then there's a cluster admin who has the full access to the cluster. And then the cluster admin will basically try to install the driver and then do a few modifications on the cluster so that it could be consumed correctly by the application. And the last role is the application developer or the DevOps. So the DevOps, what they do is that basically they've given the access to the cluster. They don't install the drivers because they don't have the full access to the cluster. They're not the cluster admin. But these people are like, they have the better visibility into the application. So they basically know how much of the resources their application need, what kind of resources the application requires and how much requires, what are the configurations and so on. So these people have like better understanding about the application itself, and then they know the resource requests basically. And the thing is that you could be basically application developer at the same time plus the cluster admin, and you could be even the driver developer at the same time. It's not a strict role, but it's just like how how the roles are basically spread between each other. So now let's try to play some of these roles. I said some of these because we cannot play the role of the driver developer right now because we don't have that much time. So we're not gonna write the driver right now, but we will consume some of the drivers that exist already publicly on the GitHub. But we will try to start acting as a cluster admin initially. So if you still are following me, the cluster admin will start installing the drivers. So most of the drivers that are publicly available, the installation method is very simple. So you just run the helm command and then try to install the driver, and that's it. So let's say we're going to pick the driver that is called CPU, the array driver CPU. So you could assume what it does. It basically tries to allocate and manage the CPU resources, right? So we will install the driver as a cluster admin. Then the next thing what we can do, what we're not forced to do, but we can do, is that we could try to analyze what the driver did. So the moment that you install the driver, it automatically kicks in, and then it basically scans the node and tries to, let's say, analyze the resources that it takes that it's responsible for. For in our case, it's a CPU driver, so it will go into the node. The pod is installed on the node, right? Then it scans the node and tries to, for example, count how many CPUs does it have, how is the architecture of the underlying CPU, how are the NUMA nodes are located, and so on. Once it has that knowledge of the node, then it needs to give that information to the higher level so that somebody could consume that knowledge. Because only knowing about the resources is not enough. You need to do something meaningful out of the resources. You need to consume that and act upon that. So it will basically install or create a resource called resource slices on every node. So one resource slice per node. And then it will dump all the information into the resource slice. So if you try to make an analogy of this resource slice, it's basically like a menu of the restaurant. So when you go to a restaurant, for example, you have list of the different variations of the osh, for example, with all the ingredients, right? Resource slice is the same. So it's gonna say, okay, on this node, we have the CPU, for example, 001 that has the core ID this, the cache is this, the NUMA node is this, and so on. So it will basically all get that information and dump into this resource slice object. So, and then there is a thing called, within this resource slices, there is a thing called attributes. So the attributes is basically the ingredients of the plov that you consume. For example, for the chochonaosh, you have beef, eggs, chickpeas, like blah, blah, blah. So it's a similar thing in the resource slices. So resource slice basically has list of the attributes for each resource. And it's going to say, for example, for this object or resource, there's this much GPU, this much memory, this much core, and so on. So what we did, just to recap, as an admin, we installed the driver. Driver automatically created the resource slices for us for every single node that we have on our cluster. It found all the information that it needs, and then it populated into this attributes, for example. And the next thing is that as an admin, what you could do, but you're not forced to do, it's optional, is create another object called device classes. So the device classes is basically sort of categorization of the resources that you have. So let's say you could create as a cluster admin, this is not the DevOps team, but the cluster admin, what they can do is that they will create different variations of the device classes and try to match some of the nodes that have something in common. For example, admin can create a device class called high performance and then try to put the nodes that are really meant to run high performance workload, right? So for example, high performance, we have, let's say, n number of the servers on our cluster, and then server A, B, and C are really high in the CPU. So we assume that they are really good for the high performance applications. Then you could create, for example, general purpose device class that is okay to use for logging, monitoring and stuff like that. Or for example, you could create another device class for, let's say, a specific architecture for ARM or for Intel and so on. So it's basically you're just grouping the nodes into groups, and then then you would expect these categorizations to be used by the application or by the DevOps team, basically. So that's the end of the story for the admin part. Now, if you try to see how it looks like in practice, so device class looks something like this. It's just one example. So we're creating the object called device class that has this high performance name. So we're creating this one, for example. And then in the expression, this is common like cell, basically. We're saying, hey, for this device class, I want you to group the nodes that have the driver, like that has the CPU intel.com, that is specific CPU, basically Xeon, that has, for example, more than 32 cores, more than or at least equals to 256 gigabytes of the memory, and then there's a turbo boost enabled. So it will try to match your expression, and if it can, like by it, I mean the D array, if it can match, then it will create this device class for you so that the DevOps team can use it. So just to recap again for the admin, so the admin basically created or installed the driver, created the device classes. Now it's time for the DevOps team to actually consume those resources. So the question is how the DevOps team is going to consume those device classes or the resources. So for that, they need to ask, right? So you have the DevOps team, they know what is needed for their application. Now they need to ask, okay, for my application or the workload, I need this much GPU, for example. So the way that they ask is in the format of the object called resource claim. So it's very similar to the volume. If you work with the volumes, there's a volume claim. It's the same mechanism basically under the hood. So basically with the resource claim, you just ask, hey, can I have, for example, Cherchona Osh with double meat and less oil? This is the request that you're giving for the pod. It doesn't mean that it will be like it will be allocated, because if there is no resources, of course, it won't be allocated. But if there is, then well, you're lucky, and then your pod gets created because there's enough resources or there is enough OSH with double meat and less oil, for example. But then let's see just one example of this resource claim, how it looks like. So this is the resource claim that, for example, DevOps team will create for their application. So it's object resource claim, it's namespaced object, and then here you can specify the devices that you need for your workload. And then it's basically array or the list of the objects that you can give. And then, for example, here I'm specifying two lists. One is called Xeon Gen 5 large, and then the other one is Gen 4 medium. And if you look at here, there's this field called first available. So the thing is that with this, what we could do is that basically we're saying, hey, can you try to find Xeon CPUs Gen 5 large? And if for some reason you cannot find or fulfill my request, I'm okay to go with Gen 4 medium as well. So it's basically saying, can I have an OSH with less oil? But if that's not possible, I'm okay with normal oil as well. So it's basically first available means give me this if you can. If not, well, I'm okay with this one as well. And again, in the cell expression, in the selectors, you're specifying exactly your preferences or what you need. So basically the CPU architecture or like the cores, memory, blah, blah, blah. And similar story here. Now, if you notice that the object I said is called resource claim, but if you're familiar with the volume, there is also a template as well. Similarly, here we have the resource claim template. So the template is that instead of you creating the resource claim in advance, you could just create a template and just reference into this template from your workload. So that means you don't have to create the resource claim by yourself in advance. And it will be only created whenever there is an actual pod that is created. So let's say you create the pod, you reference to the resource claim template, the resource claim template, based on the spec, it will basically create the resource claim for you and then try to match the resource that you have. But the spec is exactly the same. The only thing is that it's just resource claim, not the resource claim. Sorry, it's resource claim template, not the resource claim itself. We could probably skip this part. And then just to recap again, on a high level, this is the whole architecture. So you have your Kubernetes nodes, let's say node 1, node 2, that has some driver up and running. Then on the left side, you have your application pod or your workload. In the workload, you are basically, whenever requesting resources, you just specify the resource claim name, for example, my claim, or you could specify like here, or you could specify the claim template, yeah, like I just showed. Once you install your pod or create your pod, and then the resource claim is created, so those requests are going through the API to the DRA API eventually. What happens is that if you remember at the beginning, I showed the resource slice object that is created by the driver automatically. So the question is, who is the consumer of the resource slice? So it could be the cluster admin. So the cluster admin can look at the resource slice and say, oh, okay, on this node, I have this much CPU or this much GPU, FPGA, whatever. But that's not the main intention. The main intention is the kube scheduler and then the kubelet. Basically, the scheduler and then the kubelet are the main two like consumers of the resource slice. So they basically read the resource slice and try to read what you're requesting on the left as like the pod, and then try to match these requests and then available resources. So that's why basically they stay kind of at the center. So they read the resource slices, they read the requests on the resource claim, and then if it matches, well, congratulations, the resource is allocated. If not, the pod is staying in the pending state. But DRA isn't only about the GPU resources. Sure, it was originally created for managing or allocating the GPU resources, but eventually it ended up to be bigger than that. So nowadays with the with the DRA, you could also allocate even the native resources, actually, like CPU, memory, huge pages, and so on. So those resources that you allocate normally on the pod spec. You could allocate network interface cards. There's a project called DRA-Net, which is basically for the networking related resource allocation. So you could say, give me this much bandwidth for my pod, or give me an interface that has this much bandwidth for my pod. So you could also request RDMA network devices and so on. It's quite rich. So it's not only about GPU anymore, and it's also going into direction of the native resources. All right. I think I'm on time. I'm tracking my time here. So, but let's see it in practice. So now you could just sit back and relax, and I'll try to play the demo, and hopefully I don't mess up my demo and there is no demo effect. So now I need to move basically my terminal. Let's see if I can do it. All right. Could somebody confirm that you can see my terminal? And is the text big enough?
Друзья,
Yes, no.
друзья, вам нормально читать? Все нормально? Yeah, that's good.
Oh,
Yes.
okay. So what we
readable.
have is that we have the Kubernetes cluster. It's just a kind cluster, nothing fancy. We have, I think, 3 nodes, if I'm not wrong. Yeah. So we've got 3 nodes, 2 workers, 1 control plane, running on containerd, almost the latest version. If I have time, I will explain why I'm mentioning about this. So what we want to do is that first, as a cluster admin, we'll install the driver, CPU driver. Then as a DevOps team, we will create the pods as a workload and then request some resources, CPU resources for our workload in the DRA format. Okay. So I don't have the driver installed right now, but I will do it in a moment. So I have the project called DRA driver CPU, like I said earlier. So, and I will use the Helm to install this driver. So not to waste my time here, I will try to explain what's going on here in a moment. So what we're doing is that basically I'm saying, hey, install me this driver that is locally available. So I'm using the local charts, Helm charts. I'm overriding the container image that it's using for the driver. And then I'm also specifying the mode of this driver. So basically in the CPU driver, there are two modes, but we don't need to go into the details, and I'm going to use the individual mode right now. And then I'm also specifying the namespace as the kube system, right? So if I install the driver, it says, okay, fine, installed. Now let's check the Helm first. So the drivers is deployed, the correct version in the kube system namespace. So let's check the pods now. The pod is still trying to get the image probably. All right, so the pod is running now, and if I try to get one of these logs, just to make sure that everything is correct, that kube system. All right, the pod is fine. It started the resource class, resource class controller. So if you remember, once you install the driver, it analyzes the node and reports everything that it found on the node in the format of the object called resource slice. So now let's see what it did. I will just check for the resources via the resource slice object. It says, okay, I created 3 resource slices because we have 3 nodes on the cluster. Let's check the control plane one. And if I do OYAML, it's huge. The reason is, I will tell you why. Because on this node, we have 128 cores. So it's going to basically have 128 attributes, and each attribute is the list of the objects, like information. So I'll just pick the last attribute. So think of this as one type of the OSH, right? This is Chohona OSH. There's also, I don't know, Tuyosh, there's Zagar OSH, whatever. So this is Chohona OSH, basically. This is just one resource. So resource is CPU, basically, and then there's a core ID 22, and then there's a CPU ID 127. It says, okay, SMT is enabled. If you know what SMT is, then there's a socket ID, NUMA zone, and so on. There's enough information about one particular core, and that is given by, or that is found by the DRA driver itself. So now what I will do is that I will create a workload. So basically the pod, this pod, the pod will have the name give me OSH please, and inside the pod we will create or request creation of the 2 containers. One container is called Tuyoshe, the other container Chohonaosh. For the Tuyoshe, what I want is that I want 4 CPU, like 4 cores. For the Chohona, I want 6 cores. So, but that's not enough, because what we're doing is with the DRA, right? So we should use the DRA resource claims. So the way that I do is that I'm saying here that, hey, also create, like, I'm putting the reference to the resource claim and saying for the, sorry, here, for this Chohona OSH, I want you to use the Chohona OSH claim. And for the Tuyoshe, obviously, I want to use Choi Tuyoshe claim. So if I create the pod, the claim is not created. So I'm going to create the claim as well. Claim is the way to ask for the resources. So we will create 2 claims, Tuyoshe claim that is saying use the device class that has the name DRA CPU. And for the Chohonaosh, the same device class called DRA CPU, right? So let's do that. So if I do kubectl, first let's check the pods that we don't have those. So we don't have the pods in the default namespace. Now if I create our OSH request, so it says, hey, I created 2 resource claims and then 1 pod. So if you check the pods now, it says pod is created, it is running. Well, that's good, but that's not enough. Let's check a little bit how it looks on the spec or on the status. So I'll maybe move this a little bit up. So if you look at the status, it says allocated resources for 1 container 4 cores, and there is another one that has allocated 6 cores. So it basically did the job, but we want to see the resource claims, right? So the claims should be there, and you can see there are 2 claims. If I take the Chohona OSH claim and try to grab the information, it says, hey, I am allocated. It's attached, and it says this was requesting 6 cores, and I took the course number 004, 05, 06, 07, 08, 09. Right? So it took whatever it need through the DRA driver. And if you look at the driver ports again, all right. So, for example, this one, and if we check the, sorry, not the logs, not the spec, but let's check the logs. I should remove the get. Yeah, nothing fancy here. I think we could actually skip this part. But that's pretty much it that I wanted to show. And I hope that I still have some time for questions. And if you have questions, you could ask me either now or you could try to contact me on the Slack. I'm available on the Slack with this handle. The driver that I use right now for this demo is the CPU driver. It's called DRE CPU driver. You have the link, you will have the slides in case you don't have to take pictures right now. And then if you're interested in other driver, for the networking, it's DRNet. But if you want to know all the drivers that are available publicly, there's a separate working group under the Kubernetes 6. It's called Working Group Device Management, and you can see all the list of the drivers that are available. That's all from my side. Thank you for listening, and I'm open for questions if we have time. And if there are questions, somebody will need to help me to deliver it to me.
Okay. Feruzjon, thank you a lot. That was truly impressive. Друзья, давайте поблагодарим Feruzjon.